In water-scarce region, arid climates, or any open water bodies, there is a huge loss of water in the form of evaporation. In this lecture, we will discuss or learn various methods to reduce evaporation. There are various methods which can be adopted to reduce the water outflows in form of evaporation. We will learn all these methods in detail in the subsequent slides. One of the most fundamental ways to reduce evaporation is by reducing the surface area. Evaporation rate is directly proportional to the surface area of the water body. The larger the exposed water surface, the more water molecules can escape into the air. At the same time, evaporation is inversely proportional to the depth of water body. Deeper water bodies have more thermal mass, so they heat up more slowly, experiences less temperature fluctuation at the surface, and loses less water per unit area as compared to the shallow ones. So the key strategies to reduce the evaporation are reduce the surface area or create deeper lakes. The providing mechanical covers is one of the most effective physical ways to reduce evaporation. Placing a cover blocks direct sunlight which significantly reduces the water surface temperature. Lower temperature means lower saturated vapor pressure at the surface, so less driving force for evaporation. The mechanical cover over the water body cuts off wind movement directly over the water, which again reduces the evaporation. Another well-known technique for reducing evaporation is spreading chemical films on the water surface. The chemical form an extremely thin monomolecular layer over the entire open water surface. This layer increases surface tension and reduces the rate at which water vapor diffuses. This both phenomena lowers the evaporation. Cetyl alcohol and stearyl alcohol are most widely used for this purpose. Another natural and long-term method to reduce evaporation is creating a forest or tree belt around the reservoir. The trees act as a wind barrier. They significantly reduces the wind speed over and near the water surface. Lower wind velocity decreases the evaporation. The forest also lowers the air temperature around the reservoir and increase local humidity through transpiration from the trees themselves. Higher ambient humidity reduces the vapor pressure deficit, that is EW minus EA, slowing the driving force for evaporation. Another method to reduce evaporation losses is particularly from shallow groundwater or reservoir margins is removing phreatotypes trees. Phreatotypes are deep-rooted plants like mesquite, tamarisk, cottonwood, or willows. These trees and shrubs extract large volume of groundwater through transpiration, which then evaporates from their leaves, a process called phreatophytic transpiration. By selectively removing or controlling these plants, we can significantly reduce non-beneficial water loss and allow more water to stay in the aquifer or reservoir. A very effective structural method to virtually eliminate evaporation is creating underground reservoirs or covered storage tanks. By storing water completely below ground, we achieve complete obstruction of sunlight, preventing surface heating, minimum input of thermal energy from solar radiation, no wind action over the water surface, and therefore non-zero evaporation, or we can say evaporation is minimum. So these all are the method to reduce evaporation. I hope you have understood the different method to reduce evaporation. If you have any questions or query, you may drop your questions in the comment section below. Thank you. Jai Hind.